Good morning, students. This is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Now, today's our topic is problem solving related to machine learning algorithm. Now, we will see one by one. So, first one is that it takes 1 hour to train a decision tree on a training set containing 1 million instances. Roughly, how much time will it take to train another decision tree on a training set containing 10 million instances? So, as we know that the computational complexity of the training set, training a decision tree is like big O of n into m log of m. This is your time complexity for the decision tree. So here, when we will multiply the size of the training set by 10, then the training time will be multiplied by the sum factor, like we can say the k. So we have to determine value of k. Now for finding the k, you have to divide the complexity of the both. Now k is equal to n into 10m into log of 10m divided by n into m into log of m. So 10 into log of 10m divided by log of m. So here m is equal to 106, and then we will get the value for the k, that is similar near about the 11.7. So we can expect the training time to be roughly like 11.7 hours. Now next one is that, is the Gini impurity of node lower or greater than that of its parent? Now comment whether it is generally lower or greater or always lower. Now node's Gini impurity is generally lower than of its parent as the card training algorithm. According to the card training algorithm, your Gini impurity is lower than its parent. So here cost function split each of the nodes in a way that minimizes the weighted sum of its children's Gini impurities. So sometimes it is also possible for the node to have a higher Gini impurity than its parent. Now still in such cases, we can say the increase is more than compensated by the increase in the other child's impurity. Now for better understanding, first let's consider one of the example. Consider node containing the 4 samples like class A and 1 sample class B. So Gini impurity will calculated like 1 minus 1 by 5 into 2 minus 4 by 5 into 2, and after solving you will get the answer 0.32. Now you have to suppose that dataset is like one dimensional and instances arranged in manner like A, B, A, A, A. Now we can verify the algorithm will split this node after the second instance, and we have to produce child node with instances A and B, and the other child node with instances A, A, A. Now first child node's Gini impurity is like 1 minus 1 by 2 into 2 minus 1 by 2 into 2, and you will get the answer 0.5. So which is higher than the parents? For parents we got 0.32 and here we got 0.5. So this is the compensated for by the other node like being pure. So its overall weighted Gini impurity is that 2 by 5 into 0.5 plus 3 by 5 into 0. So we'll get the 0.2, which is lower than the parent's Gini impurity. Now next one, assume that you have to achieve 96% accuracy in the classification model for the cancer detection. Now what could be the conditions because of which model will fail? Are there any solutions? Let's see. We'll find out. Cancer detection datasets produce mostly highly imbalanced results. So if the dataset is imbalanced, So if imbalanced dataset should not be used for the model building. So 96% of might only correctly correctly the forecast the majority of the class, but not the rest 4% minority class who may be having the cancer. So in order, if we want to evaluate your class wise performance of the classifier, so we can use here true positive rate. True positive rate, true negative rate. True positive rate will show the sensitivity, true negative rate will show the specificity, and F measures. Now if minority class performance is poor, then we can use the undersampling or oversampling to make the data balance. Then second point is that probability calibration, we have to adjust for the prediction threshold value. Then you have to assign the weights to the classes. So because of that, minority class will become heavier. Then next one, anomaly detection. You have to detect anomaly. Then we can try this thing by using the different way. Like first you have to add more data to the data set, then feature engineering, or you have to perform the feature selection, then algorithm tuning you have to use, and the cross validation. Then you are given a table of tweets. Table shows that tweets by each user over specific period. Now calculate the 7-day rolling average of tweets by each user for every day. So here column name, tweet ID, message, user ID and tweet date. And the data types are integer, string and date time. So here we will use SQL query. And by using SQL query, we have to find out the 7-day rolling average tweets. Now first, we have to select tweet date and user date. And for that, we have selected tweet date and the user ID. Then we have to find out the average. So for average, first we have to use the count function. Count function, that is count function of the tweet ID over what? Partition by user ID. We have to use the order by, that is showing the tweet date, and the rows between three preceding and the 3 following, you have to mention it. Now you are selecting from the tweets and order by tweet date, then you will get the answer. Now next one, assume you are given data set with missing values in it that vary by 1 standard deviation from the median. Now how much of the data will remain unaffected and why? In normal distribution, generally maximum area will covered under 1 standard deviation. Always standard deviation like 1. From positive axis to the negative axis of the central tendency like 68%. From the mean or mode or median. So the total data that will remain unaffected will be 32%. Now imagine you are working on time series data set and you want to build a high accuracy model. Now you started building decision tree and time series regression model. Now you can see that time series regression got higher accuracy than the decision tree model. Now what will you conclude? You have to conclude after reading this situation. Now we know that first we have to detect the time series data will detect some linear interaction, whereas the decision tree detect the non-linear interaction. Time series will detect linear interaction and decision tree will detect non-linear interaction. So time series model is same as the regression model. Hence, it finds the linear relationship effectively. Hence, if data set is assuming like linear relationship, the time series model is best. Now next one is that label encoding doesn't increase the dimensionality of the data set, but one hot encoding does. Then how? One hot encoding create means new variable for each label is present in the categorical values. Now we can say one of the example, like we have one of the variable called animal. It has 4 labels like cat, dog, lion and a tiger. Then the one hot encoding will create 4 new variable, and those 4 new variable like animal.cat, animal.dog, animal.lion and animal.tiger. So while labeling, while label encoded variables like 0 or 1, hence we can say it doesn't increase the data dimensionality. Next, how does the random forest algorithm give predictions on an unseen data set? Now here, after training the algorithm, each tree which is available in the forest, it will give the classification on leftover data. So we can say the tree votes for the class. Then finally, forest will chooses the classification which having most vote overall the trees in the forest. So binary dependent variable, the vote will be either yes or no, and finally it will count up the yes vote. So this is the random forest score, and the percent yes votes received is the predicted probability. So in the regression case, it is the average of the dependent variable. Now let's consider one of the examples. Suppose we fit 500 trees in the forest, and in case is out of bag in 200 of them. So 160 trees vote class 1 and 40 trees vote class 2. So now in this case, random forest score is score class 1, since the probability for that case would be 0.8, which is like 160 divided by 200. And similarly be an average, the target variable for the regression problem. Now next one is, prove that in the bagging method, only about 63% of the total original examples, that total training set, so appear in any of sample bootstrap dataset. Now you have to provide the proper justification. First, we have to explain the input and label training examples like S. So S is equal to xi, yi, and here I is equal to 1, 2, 3 up to n. Now we have to select n sample out of the n with replacement to get a training set Si, and still different from working with the entire training set. So now PR of Si is equal to S, that means n factorial divided by n to the power n. So very small number, that means exponential small in n. So after that we'll get the answer P of R xi yi not in S. And for that 1 minus 1 by n to the power n, that is e to the power n, and value will be 0.37. E to the power minus 1 is equal to 0.37. So hence we can say that the 37% of the data is left out. Now next one is, you are given data set consisting of variables with more than 30% missing values. Now how will you deal with them? Now here there are different ways for handling the missing data values. If data set is large, if your data set very large, so definitely we can just simply remove the rows with missing data values, and we can use very quickly. So we can use the rest of the data to predict the values. Now if you have the smaller data set, then we can substitute, then we can replace some missing values with the mean and the average of the rest of the using, like pandas, we can use pandas data frame in Python. So there are different ways to do so, such as df.min, df.fillNA-min. Now next one is, how will you calculate eigenvalues and eigenvectors of the following 3 by 3 matrix? So values are -2, -2, 4, -4, 1, 2, 2, 2, 5. Now let's see. Here equation is that first we have to find out the determinant. So determinant, -2 minus delta, 1 minus delta, 5 minus delta, 2 into 2. So -4, when you will keep all values, you will get the determinant like 0. So here algebraic equation built from the eigenvectors by heat and a trial. So 33 minus 4 into 32 minus 27 into 3 plus 90, that is 0. So now we'll get the delta minus 3 is a factor. So minus 4 delta 2 minus 27 delta plus 90. Now we will get the delta minus 3, delta 2 minus delta minus 30. So now eigenvalues you have 3, minus 5 and a 6. Then after that, delta minus 3, delta 2 minus delta minus 30, then minus 3 plus 5 minus 6. So we have to find out the eigenvector for lambda is equal to 3. Now x is equal to 1, minus 5 minus 4y plus 2z is equal to 0. Now you have to subtract the two equations. You will get the equation 3 plus 2y is equal to 3. Now subtracting back into the second equation, again you will get the answer minus y is equal to minus 3 by 2 and z is equal to minus 1 by 2. So similarly we can find out the eigenvectors for the minus 5 and 6. Next, how can you calculate the accuracy using confusion matrix? So consider the confusion matrix like actual, positive, negative, here predicted, positive, negative, true, positive, false, true, negative. Now you can see the values for the total data, actual values and the predicted values. Right? The formula for the accuracy is equal to true positive plus true negative divided by total observation. True positive value 262. True negative value 347 and the total observations are 3650. And after that, you will get the 609, 650 divided by 0.93. So we get the accuracy like a 93%. Now write the equation and calculate the precision and recall the rate. So consider the same confusion matrix used in the previous equation like actual, positive, negative and predicted values, positive, negative, true, positive, false, negative and true, negative. So again, total are 650, actual is P and N, predicted P and N. Those values they are given, positive, false, positive, true, negative, true, positive, false, negative. Now precision you have to find out. Precision is equal to true positive divided by true positive plus false positive. And recall rate, if you want to find out the recall rate, then true positive upon true positive plus false negative. So true positive, first we have to find out the precision. True positive 262 and true positive plus false positive like 277 and you will get the answer 0.94. Now recall rate we have to find out. The true positive is 262, false negative 288. Now you will get the 2.90. Now next one, 3 ants are sitting at the 3 corners of the equilateral triangle. Now each ant randomly picks a direction and starts to move along the edge of the triangle. Now what is the probability that none of the ants collide? So this situation is like implicit. So this is the case of independent event. Each ant can randomly pick the direction, either left or right. So the decision of one ant to go to the left would not affect the decision of other 2 ants whether they want to go to the left or right. So since the decision is random, so the probability of an ant to pick a certain direction is like 0.5. So 3 ants would not collide if all of them go to the left or all of them go to the right. Now 3 ants would not collide if all of them go to the left or all of them go to the right. So we can say that P of none of the ants collide 1 by 2 cube 1 by 2 cube is equal to 1 by 8 1 by 8 2 by 8 1 by 4. So probability of none of the ants will collide, that is 1 by 4. Next, how to find who cheated on essay writing in a group of 200 students. So there are different ways on how we can find who is cheating in an exam. So one way to do this is by comparing a pair of student exam one by one. So if we think that compare the exam of student A with student B, that is the same as comparing the exam of the student B with the student A. Then second one, in other words, we can say A comma B is equal to B comma A. That means order doesn't matter. Then order doesn't matter, then we can use the concept of the combination. Now how will we use? What is the equation of the combination? That equation of the combination is C of n comma k is equal to P of n comma k divided by k. So n factorial n minus a k factorial k factorial. So n is your total number of items and k is your total number of items to be ordered. So there are 200 students and there are 2 exams that will be compared we have. So we can say that C of 200 comma 2, that is 200 factorial divided by 200 minus 2 factorial into 2 factorial. So we'll get the answer 200 factorial divided by 198 factorial into 2 factorial. Now next one is that 3 people and first, second, third place at the competition. How many different combinations are there? Now we can check. Here definitely in this question for us order will matter because it's related to position. First position is not the same as the being second and third. So this means here we have to consider the position. That means if we have athletes ABC and their positions are like 1, 2, 3, then the composition of ABC is not the same as the CBA or BAC. So thus we can deal with the concept of the permutation. We can use the permutation concept here. And what is saying that permutation concept? P of n comma k is equal to n factorial into n factorial minus k factorial. So here n is your total number of items and k is your total number of items to be ordered. So according to question, we have 3 athletes. And their places also 3. So we can say P of 3 comma 3 we can find out. 3 factorial divided by 3 factorial minus 3 factorial. So 3 factorial is equal to 3 factorial, that means 3 into 2 into 1, that is 6. Now we have 2 options for serving ads within newsfeed. Out of every 25 stories, one will be an ad. Every story has 4% chance of being an ad. Then for each option, what is the expected number of ads shown in 100 news stories? If we go with the option 2, what is the chance a user will be shown only a single ad in 100 stories? So this question is related to like PMF. Here we are expecting that expected value and PMF of binomial distribution. So first question, which is expected the number of ads shown in 100 news stories would be. So E of ads shown 100 into 4 by 100, that is 4. That means second question is answering that will be with the PMF of the binomial distribution. So total number of trial is 100 and the total number of success is 1. So and every story has 0.04 probability of being an ad. So P of x is equal to 1. 100 divided by 1 into 0.04 into 1 minus 0.04 to the power 99, that will be 0.07. Now let's say the population on Facebook clicks ads with the click-through rate of P. Now we select the sample size N and examine the sample's conversion rate. Denoted by hat of P, what is the minimum sample size n such that probability of ABS hat of P minus P less than delta, that is 95%. And in other words, we can say find the minimum sample size n such that our sample estimate is hat of P, each within the delta of the true click-through rate P with 95% confidence interval. So here conversion rate of the question follows like a binomial distribution, and which means it shows that we need to find out the standard deviation with the square root of the variance of the binomial distribution. So general equation we can use, general equation of the variance of binomial distribution use like variance of x is equal to p 1 minus p. So through the question we know that the 95% confidence interval is available, which will translate to z score equals to 1.96. So plugging this equation, you have to keep properly answer. That means 1.96 into root of p 1 minus p divided by n. And you will get, that means n is greater than or equal to 1.96 square into p 1 minus p into delta square. Now you are about to get on a plane to settle. You want to know if you should bring an umbrella. You call 3 random friends of yours who live there and ask each independently if it's raining. Each of your friends has 2/3 chance of telling you the truth and 1/3 chance of messing with you a line. So all 3 friends tell you that yes, it's raining. What is the probability that it's actually raining in Seattle? So answer this. We have to assume some probability of rain in the Seattle. We can assume that 0.5. So each of our friend has like 2/3 chance of telling the truth, and probability of rain settle given our friends say that it will be raining in settle would be like 2/3. So likewise probability of not raining given that our friends say that it won't be raining in settle, that will be 2/3. So based on this we can define minus a is like raining in settle, a not raining in settle, and xi is like random variable Bernoulli distribution where value of this variable represent answer of friends, raining of 1 or not raining 0. So we can approximate the probability that it will rain in Seattle given that our friends say that it will rain with the Bayes theorem. So here we can use the probability of A given x1 is equal to 1 intersection x2 is equal to 1 intersection x3 is equal to 1. So after that you can keep the values like that. 1/2 into 2/3 cube divided by 2/3 cube into 1/2 plus 1/3 cube into 1/2. So after solving you will get the 0.888. So these are the references. You can go through this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.